Welcome to Digital Electronics EEE 301. In this lecture, we'll discuss about multiplexers and demultiplexers and encoder and decoders. Let's start with the multiplexer. A multiplexer has n control input and 2 n data input, also 1 output. This is a typical 2 to 1 multiplexer. So it has 1 control input, so this is our control input A, and 2 data input. So if you look at here, n equals 1, that means 1 control input. If n equals 1, then 2 to the power 1 equals 2, so 2 data input and 1 output. So this is our output, Z is our output. So this is a typical representation of multiplexer, which acts as a switch, like depending on your n, depending on your A, I mean control input, so it selects either I0 or I1 to the output set. A multiplexer routes or connects the selected data input to the output. The value of the control input determines the data input that is selected. Just look at here. As discussed already, this is a 2 to 1 mask. So this is our control input and this is our data input. So n is our control input, n equals 1, and 2 to the power n, so 2 to the power 1, 2, so 2 data input, so which is known as I0 and I1, and this is our Z output, and this is the typical representation of this mask, which acts as a switch. So if we look at the Z equals, so we have two combination actually. For A could be either 0 or 1. So single bit have two combinations, 0 and 1. So Z equals, when A equals 0, it is actually A prime. A prime. So when A equals 0, it selects I0 to Z. I0. That means 0 input to Z. When A equals 1, it selects I1. I1 to Z. Something like that. So it selects I0 to Z or I1 to Z. So then we can represent Z equals, when A equals 0, A0, I0. So A0 means A prime dot I0 plus, that means, or A equals 1, then A dot I1. So this is the typical representation of 2 to 1 mask and its output equation. Now look at here. So we have now two control input, A and B, and if we have two control input and data input is 2 to the power 2, 4, that means I0, I1, I2, I3, 4. This is a 4 to 1 mask, that means we have 4 input, 1 output. Z is our output. Here the important thing is we have the MSB, most significant bit, and LSB, least significant bit. So like here we have 4 inputs, so for 2 control pin, so we have 4 combinations, that means 0 0 0 1 1 0 1. If you look at here our AB, it could be 0 0 0 1 1 0 1 1. So what it does, when our input is 0 0, it selects I0 to Z. When our input is 0 1, it selects I1 to Z. When 1 0, I2 to Z. 1 1, I3 to Z. So that's why, so 0 0 I0, 0 1 I1, 1 0 I2, 1 1 I3. So look at here, so our B is LSB, least significant bit. So if you look at here, 1 1 or 1 0, this is least significant, 1 0, and this is most significant, A is most significant bit. So remember that one whenever you are writing the truth table. So if we write the equations for Z, so Z becomes our A0 B0, that means A prime B prime, A prime dot B prime dot I0, then A prime dot B dot I1 plus A dot B prime dot I2 plus A dot B dot H. So that will be our truth table for 4 to 1 mask equation and truth table. Now look at 8 to 1 mask. So we have for 8 bit, so we need 3 control input. So 2 to the power 3 means 8 data input. So 8 input and 1 output. That's why it is called 8 to 1 mask. So similarly, we have 0, 0 to 1, 1, 1, 7 up to 7, right? So whenever we have 0, 0, 0, so it selects 0 I0 to Z. Whenever we have 0, 0, 1, I1 to Z. Whenever we have 0, 1, 0, then I2 to Z. Whenever we have 0, 1, 1, then I3 to Z. Whenever we have 1, 0, 0, I4 to Z. 1, 0, 1, I5 to Z. 1, 1, 0, I6 to Z. 1, 1, 1, then I7 to Z. So this is our complete truth table. So this is our final F. You can write F or you can write Z as well. So Z becomes then similarly. So A prime B dot B prime dot C prime into I0 plus A prime dot B prime dot C into I1. So go up to I7. It's the same thing. So this is the typical circuit representation. So you have so I0, just the equation, whatever you have, A prime B prime I0, A prime B prime, sorry, A prime B prime C prime I0, then A prime B prime C I1, A prime B C prime I2 up to A B C I7, because they are all AND gate, and in between there was plus sign, so OR gate will be connected through the OR gate, and that will be used Z. So AND gate connected to OR gate, and this is our output Z. So here is couple of examples. So this is your assignment actually. So I suggest you try it by yourself. What it says, design a 8 to 1 multiplexer using 4 to 1 and 2 to 1 multiplexer only. So you can use 4 to 1 multiplexer once. You can use 2 to 1 multiplexer once or more than once if needed. So you need to use 4 to 1 and 2 to 1. So this is your assignment. Try it by yourself. If you find any difficulties, then maybe we'll discuss in the class. Another assignment, design a 16 to 1 multiplexer using 4 to 1 multiplexer. So only 4 to 1 to 16 to 1. You may need couple of 4 to 1 multiplexers. So I usually some hints that do it very soon. Now let's start with demultiplexer. Demultiplexer is the inverse of the multiplexer, you can say. A demultiplexer has n control input, 1 data input, and 2n output. So in the multiplexer, we had basically n control input, and we had 2n data input and 1 output. This kind of reverse input and output is reverse. So that means, just look at here. So you have 2 control input. So 2 control means 2 to the power n to the power to 4. So 4 2 to the power n output, 4 output, and we have 1 data input. So a demultiplexer routes or connects the data input to the selected output. The value of the control input determines the output that is selected. A demultiplexer performs the opposite function of the multiplexer, as we already discussed. Just look at here. So this is 1 to 4 demultiplexer, you can say. So 1 input, 4 output. So the same thing, like We have two control input, so we have four combination: 0 0, 0 1, 1 0, 1 1. Whenever 0 0 input is 0 0, so I is connected to output 0 or W. Whenever 0 1, I is connected to X. 1 1 is connected to output to Y. 1 0 Y and 1 1 Z or output. So this is the truth table. So then if you write the equation, so it becomes W equals, if you look at here, so W equals A prime B prime into I. For X it becomes A prime B into I. For Y it becomes A B prime into I. For Z it becomes A B into control into input equals output.